9-6, solving rational equations and inequalities. So rational equations are easier to solve if the fractions are eliminated. So we've done these when we were dealing with them earlier in the unit, and we were adding and subtracting them, we were keeping those denominators, but now we're going to try to get rid of them. You can get rid of the fractions by multiplying each side of the equation by the least common denominator, or you'll see that as the LCD. All right, so we still need to kind of figure out what our common denominator would be if we were going to add them together, but instead we're going to multiply by that to get rid of all of our fractions. All right, so I got a 24 in my denominator, a 3 minus x, and a 4. So if I were going to make a new common denominator, it would be 24 and 3 minus x. Four, notice, is a factor of 24. So if we multiply by 24, then we should get that guy to cancel. So I'm going to take my whole equation, and I'm going to multiply everybody by 24 times 3 minus x. Okay, now you have to distribute it to everybody. When I distribute that, and I'm going to write it all out so you can see it the first time, it helps us cancel things out. All right, so like I said, I'm going to write it all out. So this guy is 24 times 3 minus x times 5 over 24 plus 24 times 3 minus x times 2 over 3 minus x equals 24 times 3 minus x times 1/4. Okay, now I can cancel some things out and see if I can get rid of the denominators, which I should be able to because we chose our least common denominator. So I can cancel the 24, and then I can cancel the 3 minus x, and over here I can reduce the 4 and the 24 and make that guy a 6. Alright, so I'm going to go up here to the top. So here's what I have left. I have left 5 times 3 minus x, or 3 minus x times 5, plus 24 times 2 equals 6 times 3 minus x, times 1, essentially. Alright, now I'm going to distribute, so 15 minus 5x plus 48 equals 18 minus 6x. Combine some like terms. Let's go ahead and add 6x over here. So I'm going to get 1x. 15 and 48 gives me 63. Equals 18. Subtract 63, so x is negative 45. All right, now it says check your solution. What it means by that is we can't divide by 0. Remember, if we get a 0 in the denominator, then you have something that's undefined. So what we need to do is we need to check this guy and make sure that anywhere I don't get a 0 in my denominator. All right, well, I don't plug anything into that, so that guy's fine. 3 minus a negative 5 gives me 48, so that guy's okay. And my denominator there is 4. I'm not plugging anything into it, so x equals negative 45. And it works. Any possible solution that results in a 0 in the denominator must be excluded from your list of solutions. Remember, this is called an extraneous solution. So sometimes we do everything right, and it just doesn't work out. It doesn't work when we go to check it in our problem. Okay, number 2. Well, it looks like I'm going to have to do some factoring first of all. So I have a denominator here of p plus 1, and I have a denominator here of p squared minus 1. And this guy's hanging out, and he's got a denominator of 1 as well. So I'm going to go ahead and factor this guy. He's the difference of squares. So p plus 1 and p minus 1. find our least common denominator. Remember, if it's in 1, it's got to be in the new one. All right, so my least common denominator better have a p plus 1. This guy also has a p minus 1. And then 1. You can add that in there, but it's not necessary. All right, so I'm going to multiply everybody by p plus 1, p minus 1. All right, here we go. P plus 1, p minus 1, times p squared minus p plus 1 over p plus 1. I'm going to go ahead and write it out for each one, too. P plus 1, p minus 1, p squared minus 7. I'm going to write this guy in his factored form, so it's easier to cancel. Times, or plus, excuse me, p times p plus 1, p minus 1. All right, here we go. I got a plus 1 and a plus 1. That denominator's gone. Plus 1, minus 1, minus 1. And this guy had a denominator of 1, so he's just hanging out with us. All right, so here's what I have left. P minus 1 times p squared minus p plus 1 equals p squared minus 7 plus, that guy's the difference of squares right there, so I'm going to go ahead and write it just to save room. P times p squared minus 1. All right, we got some more multiplication to do. Distribute a p minus 1 to everybody here, so I get p cubed minus p squared plus p minus another p squared. There's lots of p's. Plus p minus 1 equals p squared minus 7. I'm going to distribute this p now, so p cubed minus p. Holy cow, that's a lot of p's. Here we go, let's combine some like terms. It looks like we got a p cubed minus 2p squared plus 2p minus 1. And then I'm just going to rearrange these guys over here. P cubed plus p squared minus p minus 7. Alright, now let's get everything on one side. Notice that I get my p cubes to cancel. This guy's negative, so I'm going to add him over here. So, going this way. Add that guy right there, so I get 3p squared. I'm going to subtract 2p, so I get minus 3p. And I'm going to add 1, so I get minus 6 equals 0. Alright, now I got see a square, so I'm going to think, oh, I might have to factor, I might have to complete the square, see what's happening here. But notice how they're all a multiple of 3, so I'm going to divide everybody by 3. So I get p squared minus p minus 2 equals 0. Let's go ahead and see if he factors. I have a minus and a minus. So my signs are going to be a minus and a plus. Multiplies to 2, subtracts to give me 1, or if you like to do it with the signs, multiplies to negative 2, subtracts to give me negative 1. That would be negative 2 and positive 1. 0 product property, I can set those guys equal to 0. So p equals 2 and p equals negative 1. Okay, now remember we're not done. We got to check our denominators. So anytime I plug in 2, I can't get a 0 on the denominator, and anytime I plug in negative 1, I can't get a 0 on the denominator. Alright, so if I plug in 2, I get 3, and if I plug in 2, I get 4 minus 1, so 3 as well, so 2 is okay. However, when I plug in negative 1, negative 1 plus 1 is 0. That guy can't work. We got an extraneous solution. So this guy only has one solution. Even though we did everything right, and we got 2 and negative 1, The negative 1 doesn't work. What I would suggest now is go do your homework for those ones, and then come back and let's talk about rational inequalities. So pause your video, go work on those a little bit, and then let's talk about rational inequalities in a second here. The difference with rational inequalities is that on these ones, number 1 and number 2, we are getting rid of our denominators. Now we're going to keep our denominators. So a rational inequality are inequalities that contain one or more rational expressions. And remember, rational expressions, just a fancy word for saying I got polynomials in my fraction. All right, now, like I said, the difference with these ones is we're going to keep our denominators. Okay? So I'm going to do everything, and I'm going to get everything on one side of the equal sign, and I'm going to keep my denominator. Alright, so I'm going to move this guy over. So I've got 2 over 3y plus 5 over 6y minus 3/4 is less than 0. Yep. Alright, so we want to keep our denominators. So if I need to get a common denominator, I got 3y, 6y, and 4. So my common denominators are 12y. Okay, so what's new? I multiplied this guy, the denominator here, by 4, so I need to multiply the top by 4. And if I multiply the denominator here by 2, then I have to multiply the top by 2. And this denominator went from 4 to 12y, so I need to multiply the top by 3y, so I get 9y. All right, combine like terms. So they all have a denominator of 12y. So in my numerator, I have 8 plus 10 is 18, minus 9y is less than 0. All right, now take a quick little peek at that guy, and notice that they're all even. Actually, they're divisible by 3. Sorry, they're not even. They're all divisible by 3. So I'm going to divide everybody by 3, and I get 6 minus 3y all over 4y is less than 0. Okay, now we're going to make 3 number lines. Our first number line is going to talk about our numerator. So if I look at my numerator, what value of y makes my numerator equal to 0? Okay, well that would be 2. I'm going to put 2 on my number line. Okay, now think about numbers in general. Numbers that are smaller than 2. If I plug in a number that's smaller than 2, what kind of value do you get? Do you get a positive value or a negative value? Okay, well let's try it. If I plug in 0, I get 6 minus 0, so I get 6, so he's positive. So numbers to the left of 2 are positive. That means that numbers that are greater than 2, like 10 maybe, would give me negative values. Alright, the second number line is my denominator, 4y. Well, what value of y makes 4y equal to 0? Well, that would be 0. Okay, numbers that are smaller than 0, if I plug them in, negative 5 would be negative. And numbers that are greater than 0 would be positive, like 10, I'd get 40. Alright, now I'm going to take the bottom guy, and he's my combination of both. So I'm going to look at them in terms of numbers, okay? So think about this guy as the whole thing. Alright, so here's my numbers on my number line. I have 0. And I have 2. Alright, so if I take the whole thing and I have a positive number divided by a negative number, you get negative numbers. And if you have a positive number divided by a positive number, you get positive numbers. And if you have a negative number divided by a positive number, you get negative numbers. Okay, so now I'm going to use this in conjunction with this less than 0 right here. Alright, so if I look at less than 0, what kind of numbers are less than 0? Well, negative numbers are less than 0. So I'm going to look at my number line here, and I'm going to find the negatives on my number line. Well, there's the negatives. So this guy, if you remember, is an OR, because he's going out. So I have y is less than 0, or y is greater than 2. Okay, let's try one more. So the trick to these is to keep the denominator, which is a little bit different. So I'm going to move the 7 over, and I'm going to make him greater than 0. So I have 7 over a plus 1 minus 7 is greater than 0. All right, now I need my common denominator. Common denominator is a plus 1, so that guy didn't change. So this guy is 7 times a plus 1. All right, squish it together. 7 minus, and I'm going to distribute a negative 7, so I get negative 7a minus 7 all over a plus 1 greater than 0. Those guys cancel. So negative 7a over a plus 1 is greater than 0. Okay, once you've got him simplified and you've got him all with one denominator, then you're going to do your number lines. All right, so first number line is my numerator. Okay, negative 7a. What value of a makes that guy 0? That would be 0. Numbers that are smaller than that. So if I plug in a negative 1, I would get positive values. Numbers to the right would be negative values. A plus 1 on my number line. What value of a makes that guy 0? Negative 1. Okay, so we'll put a negative 1 there. If I plug in numbers that are smaller than that, negative 5 plus 1, I would get negatives. Anything bigger than that, I get positives. Okay, again, the bottom one is your combined. So this is negative 7a divided by a plus 1. I'm looking at the overlap. So I have negative 1 and 0. A positive number divided by a negative number is a negative. A positive divided by a positive is a positive. A negative divided by a positive is a negative. All right, so there I'm going to use that number line. And I want greater than 0 now. So I want things that are positives. Well, here are my positives on my number line. So this guy's going to be an and. So negative 1 is less than a is less than 0. Right? So if you have a less than 0, you're going to look for the negatives on your number line. If you have a greater than 0, you're going to look for the positives on your number line. Remember, if it's the 2 on the outside, that guy's an or. If it's the 2 on the, or it's the 1 on the inside, that guy's an and. So you need to write it as a compounded